We have enough people, like for now, there are people coming later from all over the world. Maybe I can do 5 minutes just overview about the group for the guys who are new. Yes, I'm recording. And then we're gonna listen and learn from Ray. So this time we have two sponsors, not one, like the time when we were online only. First sponsor is Mining Publications. They were with us like almost 3 years now. If you do the raffle, you will be able to get a prize any of their products. And they have really good products from ebooks, video courses, live products. You're gonna love that. And Manning, if you're watching, thank you for sticking with us. Second sponsor is Google Cloud Customer Community. There are so many user groups and meetups around nowadays. Everybody's online, but this group stuck to me because they're not teaching you how to code. They're not teaching you how to get a job. They're not teaching you developer-specific things, how to certify. It's like peer-to-peer connectivity between architects and the companies. That's a place where you're going to meet your future clients and peers. And they're going to be also raffling. So we're going to do 2 raffles at the end of the meetup. They're going to be raffling the new hoodies they have. So check them out. You will get the slides. Everything's hyperlinked here. Then we're not going to go deep into serverless itself. Like, yes, we started as function as a service developers, but before you knew it, we are focused on agile mindset and achieving business agility, helping businesses through serverless technologies and through managed services. And I observed that we mesh really well with the people from the product management. So I encourage you to check out the Lean product group from California. And also there is a free conference from CPO, that's a Chief Product Officer Mastery Conference, where you're going to meet good people to work with and network with. We already scheduled 3 more meetups for this year. Next month is going to be 3 years since the group is running. So we're going to have a set of lightning talks. Unfortunately, no hugging, no pizza, but we're going to do the best we can to continue to learn. In March, we're going to have first Azure meetup. I don't know why it took us so long to get Azure presented, but I promise it's going to be a good one. Barry is a plural site trainer for Azure Architect certifications, and he's also giving away 30 vouchers for 1 month free or plural site for the first registrant to their meetup. So go to the website. We still have over 20 vouchers left. You can take any course, not just his courses, if you register. In April, we're going to have kind of scary topic like getting burned by the cloud bill. This story is circulating internet nowadays. I connected with Sudeep, who got $72,000 bill from Google. He was able to sort it out, but he's going to describe what he did incorrectly and how he set up his architecture nowadays, so we don't make the similar mistakes. So regardless of the cloud, I think this topic is going to be fun for everybody to listen to. And then later on, we need you, a volunteer for any good talks. Share, like tell your friends that we're looking for good presenters. It cannot be promotion of your own work, promotion of your company. It has to be something sharing and caring to help the community and help the world. So even if it was mistakes you made, like tell us what you did or better ways to do things. And please don't forget to rate this meetup, because the more people give us a good rating, meetup is going to show them more to the other feeds, and we're going to keep sharing this knowledge. So about this meetup, like serverless and Java, old technology, new technology, like people ask, like, why cloud native Java? Why this topic now? There were 2 reasons, 2 audiences. Like last year, I got a call from a friend who was looking to do cloud development. He was like, dude, people asking me about Docker, about EC2, about Kubernetes. How do I get into the cloud? And I replied with this Scotiabank saying, you are richer than you think. Like Java developers are more cloud native than they are. Second audience that motivated me to approach Ray to asking for this meetup is that traditionally enterprises believe that you need a platform on top of the cloud, like Pivotal Cloud Foundry or OpenShift, to run your apps and to achieve portability and avoid vendor lock-in. And that was okay 5, 6, 7 years ago, like Pivotal has its place in the history of computing. But what happened in the meantime, all major cloud vendors added integration with Java and adding ability to run Java applications as managed services. So this became kind of extra layer. And like why I challenge status quo? was that in these days, in COVID days, everybody's under the gun to cut the costs, and IT is becoming expensive. And if you use a layer on top of a layer, platform on top of the platform, you increase the complexity of the project. The development is more expensive. Support is more complicated, expensive. And cloud costs are not that optimized when you're running directly onto the cloud. And then this decreases the speed to market and innovation. So it's making IT more expensive. So you're going to go through more job losses, more rate cuts, more bleeding. And I thought it was time to stop cannibalization of IT, because there are simpler ways to do that. And it's really simple for Java developers. You will continue to develop your Spring Boot apps as a portability unit. You will use the SpringCloud libraries from the vendor you use or plan to use, and any of the cloud fully managed services to run those apps in the cloud. So tonight we're going to be covering a Google approach to that. But last September, Azure has announced, I have a link here, I'll post it, Azure Spring Cloud as a fully managed way to run Spring Boot apps. Amazon also has a Spring Cloud AWS library. They now support not only Elastic Beanstalk, but also like Fargate. And I learned that Alibaba also has libraries to help you run your Spring Java code in the cloud. So that was the reason to have this meetup, and we are really lucky to have Ray Tsang from Google. So as I mentioned, he's not just a Java guru, he's not just Google developer advocate. He developed this toolkit with his peers at Google, so he will be able to answer any questions you have. So after his presentation and live demos, we're going to have a Q&A for any questions you have to ask him. And I expect after this meetup tonight, developers will be able to walk away feeling confident they can deploy cloud-native Java in Google Cloud. And executives, if they're here, they will be able to fix this perception that they need a platform on top of platform. They can use Spring Cloud, either GCP or AWS or Azure, whatever platforms offer, and achieve agility that way. So thank you, Ray, for coming. Take it away.
All right. Thanks for having me here as well. And again, if anyone has any questions throughout the presentation, please just jump in and ask. Let me see here. It's funny, I'm using Google Hangout. I use this at work, but I'm not finding the presentation. Oh, there it is.
Mm-hmm.
All right, got it.
Bottom right. And I just realized I never presented. So you get the slides.
All right, here we go. All right. Well, and before I begin, though, I'd love to see, maybe type in the chat or something like, the type of technology you use. Are you using serverless or Kubernetes? Are you using Java, or what's your stack? Just get a sense of the audience that's listening, and also maybe what you want to learn about, particular with Spring Boot on Google Cloud today as well. So if you please type in the chat, and I'll take a look at the chat later as well. Cool. So my name is Dre. I'm a developer advocate for Google Cloud, and this is actually my very first talk of the year. I just returned from a long vacation, about 2 months in Taiwan, and hopefully I'm somewhat prepared for this. And aside from loving the technology, I also helped develop the SpringCloud GCP project. And this is the project that we're going to be talking about today, and with a lot of demos to show you what you can do. The project has been around for about 2 years now, I think, and we got lots and lots of users actually, and really, really proud of this project myself. If you have any questions, you can find me on Twitter, which is @Satanism. Okay. I see Java Spring Boot. Oh, PCF Azure, yeah. Java Spring Boot, and GK and CloudRun. That's awesome. So everyone here is using Spring Boot. That's great. So I'm gonna give you a quick example of just a 2-tier, 3-tier application here. We got the front end, the back end, and a database, right? Just do something very simple, CRUD operations, right? If you have more of these services, now you have microservices. Okay, that's how I would think about this. And one of the first questions, of course, is where do you run this? Where do you run this application? You can run this as a container in Kubernetes. You can run this in the serverless environment. We're going to get into where to run this application later as we finish developing some of the services for the demo. However, in this type of system, not only do you have to worry about where to run, but also you have to potentially use many of the peripheral services and components as well, right? So for example, the database, you have to run the database, manage the database somewhere. Maybe you need to collect trace information, or you need a centralized logger, or maybe you need metrics, you have to collect metrics. And all of these data have to be sent from your application to a server somewhere else. And so in this case, right, for the trace data, maybe we send it to Zipkin. Now you have to run and operate Zipkin. And maybe you want to use something more asynchronous. So you publish an event to a messaging system like RabbitMQ, ActiveMQ, or Kafka, or whatever. And somebody else receives the event. Now you have to manage that messaging system as well. If you want to store secrets and being able to access the secrets securely and without it, then maybe you have to run and operate Vault. And the list kind of goes on and on, right? Single sign-on, storage, and the list kind of just goes on and on. And every time that we introduce something that we think that we need to use for our architecture to fulfill some business requirement, we also have to make these other components highly available as well. Somebody have to maintain it. You have to monitor those components in addition to your application, right? You have to make sure they're not running out of space, and you also have to make sure they are highly available. I personally have installed several instances of highly available applications, plus the messaging system behind the scenes. I used to work at Red Hat, and I can say that installing and maintaining and deploying a highly available messaging system is not exactly easy and fun. It's a lot of work to do. Same thing with all of the other systems that you need to use around your application. In the cloud, it becomes very nice when we can actually find comparable components to do similar things. Maybe not exactly the same thing, but very, very similar things. And so rather than running, operating your own components in this case, you can potentially use and offload it to a service in the cloud. In which case, uh, in many of these services, the way that they're billing for these usages, they're completely serverless, right? By serverless, I mean that not only do you not have a server to manage, you are not installing and operating these components yourself, but also the billing portion of it becomes, it's billed as much as you're using it, right? It's not paying like 24/7 operation time, but it depends on how much, say, messages you are sending, or how many traces you are sending, how much log you actually have, how many secrets do you have, and stuff like that. So in my mind, it's actually very, very nice and awesome today, where we can actually develop a whole stack, the entire architecture, all without having to manage any service at all. That to me is pretty amazing, because I remember the days where we need to order these machines, we have to set these things up and configure everything to certain security standards and so on and so forth. And this thing can take a long time, right? Just the server itself probably take more than half a year to a year, right? And then you need to install and bootstrap everything else. I'm going to show you a slightly different picture of this, which is that we can actually go even a step beyond. This is actually a small snippet of what I call the anatomy of a platform, meaning that the platform itself is not just having these services being made available to you, but also having ways for you to potentially store your source code and having CI/CD pipelines that can produce the actual artifact. And the artifact can be a Maven artifact, like a jar, or it can be a Docker container image, and you have to store them somewhere as well. And then you have to use the CI/CD pipeline with the CD portion to push it into an environment. And then every environment will have its own database, secret managers, messaging system, and storage systems, and stuff like that. And then you have some serving environments that you want to run your application. And there are, as many years as I've been in the technology field, running and operating applications, they always come back to these basic things, basic needs of a application, basic needs of a service. You need an ingress, HTTP and HTTPS, customer domain names, URL mapping, traffic splitting, right? min and max instances, auto scaling. All of these things are things that we're looking for in the environment, no matter whether you are using PCF, OpenShift, or any other paths, or even if you're running Kubernetes yourself today, you might even be looking into some of these things and installing Istio and other gateways on top of it to fulfill many of these needs. And all of these services will then have to be monitored, right? With the metrics and alerts, trace, logging, and so on and so forth. And then you also have to monitor all the infrastructure too. Right? So this is why generalize the idea of every platform is more or less very, very similar. In the cloud, all of these things are mostly made available to you as well. So for example, in this demo application, what I will be creating, right? I'll use Spring and Spring Boot, but I'll also use many of these services like the database, secret management, and messaging storage. But I'm going to also store the source code on GitHub, for example, and then push it to CI/CD system, and then deploy that into CloudRun, which has all of these attributes for serving your application, the basic needs of an application. And automatically behind the scenes, we're also going to get some of the monitoring characteristics that you're going to be looking for. Okay. So that's what I want to do in the next hour. That's a lot, but being the first presentation of the year, I'm going to be conservative and say maybe I won't get to all of it, but we'll see. Okay, so the first part of it is the application itself. Right, we have all these services that we want to use, that we can potentially use to fulfill the business need. How do I actually leverage those services easily and not having to write my application in a proprietary way that only works with those services, right? And to do that, we need some kind of abstraction. And Spring Boot actually happens to have really, really good APIs, abstractions that will allow you to send traces and access database through their APIs, through their components, okay? And by doing it this way, we don't need to use our own client libraries, which is very specific to Google Cloud Services. Okay, because every one of our service have our own client libraries, and if you are tightly coupled to those client libraries, you have to write your own abstractions in order to become multi-cloud in the future. By using Spring and Spring Boot with their Spring Cloud project, there's a Spring Cloud GCP, there's Spring Cloud other clouds that starts with an A, okay, and they're all adhere to a similar set of API. And for us, we actually implemented many of these things through standard Spring Framework API. I think we have about 14 or 15 different integrations across the board for most of your application needs. And they all use standardized Spring Framework components in their APIs. But behind the scenes, the implementation has been swapped out so that they can connect to a managed service easily. Okay, so for example, I'm going to say for trace, right? If you're writing your microservices and you want to have distributed tracing, but most likely you might be using Spring Cloud Sleuth to do the tracing. And through that standard integration, by default, it's going to send the traces to Zipkin. And you can configure it to send it to other destinations, other sinks. And for us, we can actually send those traces to Cloud Ops and Cloud Trace in this case, all using the same Spring Cloud Sleuth features and functionality. Okay. Similarly, for messaging, you can actually use Spring integration that can integrate with your GMS systems behind the scenes, or you can use Spring integration to connect to PubSub messaging system so that you don't have to manage your messaging system in the future. This is really just a point and click, and then you have a globally available messaging system at your fingertip. Right? Similarly, with secret managers, rather than using Vault, you can use Spring Cloud Config, and then you can just import your secrets directly into your applications. And the list kind of goes on. For metrics, we can use Micrometer, and so on and so forth. Right? So it's probably easiest to just show how this all work. I know that we talk about using Java, but actually I'm going to try using Kotlin. Kotlin is a really nice language that runs on the JVM. It's a little bit more succinct and have really, really good features that I really like. So Also, I need to prepare for the other presentation, which I'm going to be using Kotlin. So this is going to be the one of the practices for me as well. So let's give it a try. For this, I'm going to go ahead and go to Spring Initializer. Of course, if you're using Spring Boot, you probably know this page already. This is where you can bootstrap your application. Okay, and for me, I'm going to use one of the older version here, 2.3.7, because SpringCloud GCP is still under, I think it's in RC release for 2.4.1, and I don't want to, run into any unforeseen issues. But 2.3.7 has SpringCloud GCP GA support fully at the moment. Now, one of the things that you need to do in order to take advantage of Google Cloud services and features is by adding GCP support. Okay, so on the right-hand side, if you want to add something, you can say, let me add GCP support. I already added it, so it's not showing up on the list anymore. But say you want to use our messaging system, you can just add GCP messaging. Now, as you saw in the earlier slide, we have like 14 different integrations. Spring Initializer only allows us to have 3 listed here. Okay, so we listed 3 that we think are the mostly used, and the generic one is GCP support, right? So I'm going to go ahead and just generate this application. Now, quick poll on the chat. How many people use Maven versus Gradle? There's a lot of debate on Twitter over the holidays, I think. I'm curious what everybody's using. Yes, I'm in the right place. Okay. Everyone here is using Maven. That's great. Both Gradle. Yeah. It's hard to get away with only one single build system, but I like Maven as well. For me, it's more decorative, just like Kubernetes in a way, if you think about that. Okay, cool. So I got Maven pom.xml here. You can see that this Spring Boot application has been bootstrapped by the initializer. But what is really important is right here, because I chose to use GCP support, the SpringCloud GCP project is a set of auto configurations that you can add to your project. And these auto configuration, these modules, is part of the SpringCloud release. Okay, so as of Spring Boot 2.3, we are tied to the Hoxton release of SpringCloud. Okay, so if you use SpringCloud, you can use SpringCloud GCP. Okay, what that also means is that you don't have to use rest of the SpringCloud just to use SpringCloud GCP. What I mean by that is that a lot of people, when they think about SpringCloud, they think about Netflix OSS, Eureka, and SpringCloud Gateway, and a bunch of other things. You don't need any of that, to be honest, when you're running, if you just want to use the Google Cloud services. Okay, there are 2 different things that are fully decoupled from each other. Okay. Now, let's see here. So here I have a very simple application. So what I'm going to add, what I'm going to try to do in the next, I don't know, like 20 minutes or so, is to add CRUD operation to use a database to store my data, and maybe a controller, and that saves the data, and maybe to show some traces and logger as well, and being able to send out some messages into the backend as well. All right, so that's what I'm going to try to do first. And then if we have time, I can even add a few other things, like using our ML APIs to for you to upload a photo, and then we can see what the photo is by using ML behind the scenes, which is really, really cool. All right. So the first thing I'm going to do is to talk about the database. So let me see if I can come back here. There are many different databases that you can run on Google Cloud. Of course, you can bring your own, but then what's the point? Because then you have to manage it. So some people, maybe that's what they want to do. They want to manage their own database, maybe because it's not available as a managed service. So you can bring your own database if you want to. You can run them in a VM or Kubernetes container. Obviously, I wouldn't call that serverless anymore. And you're billed by how much computing resource you're using. And then we have fully managed databases, right? These are databases that's fully managed for you. There's actually some server behind the scenes. I mean, obviously, there's always server. But the key here is that you're provisioning instances. You're provisioning fully managed instances, and you're going to be paying for those instances for the duration of the uptime of those instances. Okay, so for example, you can provision MySQL and Postgres in a highly available configuration just by a click of a button, right? But if you're running this database for 24/7 for a week, you're paying for that 24/7 for a week price, right? So is it serverless? Kinda, right? Because we host it for you, we fully manage for you, we do the upgrade for you, all the maintenance for you, so you don't have to worry too much about it. And then we have the fully serverless databases, and these are databases where you are charged by the amount of reads and writes that you are producing. So rather than paying 24/7 in hours, right? It's basically whenever you use it, the number of reads and writes and the storage that you actually have consumed, you're being charged by that. So the primary difference is that the billing unit is slightly different. However, all of the serverless databases are, I would say, NoSQL databases in this case, and they're more horizontally scalable. Basically, you don't even have to provision. You don't even need to tell us how many instances you need. Like, you don't have to say, I need 5 data store instances. You just use the API and you start storing as much data as you want. For example, data store is a NoSQL database that underlying uses something called Megastore. And that is actually what runs Gmail. The Gmail emails actually get stored into Megastore. And right, it's completely transparent behind the scenes. All right. Very quickly, Cloud SQL, just remember this. You have highly available configurations, automatic failover, and you can configure the amount of resource that you want to use, and you pay for those resources for the duration that you have provisioned them. On the other hand, I'm going to show maybe data store. Data store is a way to store just a document, so you can store key value pairs and these records as much as you want. In all cases, in all of these different databases, we all have what we call Spring Data Integration. What that means is that we provide ORM capability to all of these databases so that you can quickly access them, right? So for Cloud SQL, right, because they are just JDBC databases, you're just going to be using something like Hibernate and Spring Data JPA. But for Cloud Spanner, which is a relational database, but it's horizontally scalable, for this database, we'll have dedicated Spring Data integration because it's not exactly a relational database, right? Because of the scalability portion of it. And then for all of these NoSQL databases, obviously JDBC doesn't work. And so for these databases, we have dedicated Spring Data integration. So I can show you what that looks like directly in the code. If I can find it again, right there. Okay. In fact, let me just fix my desktop a little bit. All right. So how do you actually use one of these integrations? All of the integrations are auto configuration modules for Spring Boot. What that also means is that if you want to use anything, all you have to do is to add it to your dependencies. Okay. So for data store, for example, and just add the data store dependency. If you're using another database like Cloud Spanner, you just add the Cloud Spanner dependency. Okay. And what you also notice is that there's no version that you have to specify because the version is actually controlled by the Spring Cloud version, right? So you would never run into like version conflicts in your Java application this way, right? So we just added the data store dependency, and now my project is already fully configured to use data store. Okay, and data store is really just something that you need to enable in your Google Cloud project, and now I can use it. What do I mean by that? So for example, if I want to create a new object called person, I can just go ahead and use Kotlin here. So I can create a data class, and I have ID and name. Now for data store, for example, it can actually auto-generate the ID for you with alone. So you can annotate it with the ID annotation, just like JPA. For the entity, I also need to specify the annotation here. And now this object can interface with the data store behind the scenes. Okay, but remember, data store is a NoSQL database, so you can literally put whatever fields that you want here and whatever structure you want, and it will be copied into the destination. You don't have to specify any additional schema in this case. And then I want to create like a repository, like using a data access object to be able to perform some basic CRUD operation. And so to do that, I can just create a repository. So I got this queued up too. So here I can create an interface called person repository, and it implements the paging and sorting repository. Now notice here, this paging and sorting repository, this interface, this is the same interface you will use if you're using MySQL or Postgres, or in this case, data store or Spanner, right? So you can use the same interface to access different databases. And the only thing that you have to change out in this case will be the dependency, the auto configuration. This is really, really cool. So in a way, this can potentially help people to migrate data a little bit easier too, and migrate your application to use and adapt a new database slightly easier as well. So here I'm going to go ahead and just annotate the repository too. All right. So now this repository is ready to be used, and we can perform CRUD operation. Then I'm going to just quickly create a hello world controller here. Again, this is using Kotlin. So we have the constructor with the variable here with greeting. I'm going to get the greeting from a variable from Spring Boot, and it's going to default to hello. We're going to get to that later. Here we have a logger, so we can log a message. And then this is my get mapping where I can say hello and with the parameter called name. And then we can do something interesting here. So for example, I can now use a person repository. So I'm going to say here, this is a private val person repository. And this is a constructor field. So this is actually going to be auto-injected by Spring Boot, right? And now what I can say then is person repository dot save. And you can see that all the operation you can use here. We implemented all of them behind the scenes for data store. Okay, so you can use all of these basic operation. If none of these suit your need, you can also add your own. So for example, if you really want to, you can also say find O by name, right? And you can say the name is this, and then you can return a list of and we implemented all of these finder methods too. So we will actually, as part of Spring Data, parse this method name, and we know that you want to find O, and we know that you want to do a query on this field, and we will translate this call into the actual query. If you have some query that you want to use that you want to construct yourself, then you can use a query annotation as well, right? So you can write your own query in this case. Okay, so I'm gonna get rid of this for now because we're not using that for the demo, just so that know that it's there. And we can save. Okay, so I can save a new person, and the name is name. Okay, and maybe I'll get this back too. So I'm going to say saved. Okay, and in the greeting, I'm gonna say greeting will be hello and the name, and I'm going to also just print out the ID. So saved the ID. By the way, this is if you're not familiar with Kotlin. This is the way that you can do string interpolation, and also just you can do field. You can refer to variables directly within the string, which is really neat. All right. Okay. So that should be it. How many people think that this will just work? Nobody. Okay. Neither do I. So the only way to find out is to run it. Now, before I do it though, one thing is that how does it actually know which data store database to connect to? What about authentication? Okay, so behind the scenes, on my computer, on my machine, I already installed something called gcloud. So gcloud is the command line that you need to use when interacting with Google Cloud. And I'm already authenticated with my user account. In fact, there is another authentication here. Let me see here. Help. It is called, where did it go? Cloud auth. It's called application credential, that one. So I'm authenticated with something called application credential. What that means is that when I run this application, SpringCloud GCP will automatically detect the credential that I'm already logged in with, and it will use that credential behind the scenes for me, right? So I don't have to generate API key. I don't have to generate any additional file in this case with the key inside because the authentication is based on the user I'm currently logged in with. Okay, and this is going to be really nice in the future as well because you don't want to embed your credentials in your Docker container. You don't want to embed your credentials in your application because then if it's compromised, people can actually get access to it. So when we deploy our application, SpringCloud GCP will detect in that environment which credential to use. Okay, so we're gonna get to that later, but right now in my environment on this computer, on this laptop, the credential is automatically detected using gcloud command line, and it is known as the application default credential. Okay. The data store database that this is going to use is based on the default project. Okay, so if I say gcloud config list, this is my Google Cloud project, and so data store is tied to a project. So now whatever data I write is going to be writing to the data store on this project. Okay, if you're using something like Cloud SQL, then you have to specify the project, but also which Cloud SQL database, right? If you're using Spanner, then you have to specify which Spanner database. But for data store, it's just the project. If I want to go to the browser, if I can find the browser again, maybe this one. No, not that one. Give me 1 second. Let me just find my browser real quick. This one. So if I go to data store, usually the process here is to just enable the API, and then you can access the UI. And then here's the data store database. And I'm going to delete everything for now, just so you know this is real. Okay, and you can create whatever object that you want in here. Okay, so we're going to create something called person, right? So let me go put this somewhere else. Okay. All right, so I'm going to go ahead and run this. Hopefully this works. Crossing my fingers. Okay, and Spring Boot should run fairly quick here. All right, so while this is running, let's see if there are any questions so far. What about authentication when we deploy it for production? Yep, good question. Hopefully I answered it already, which is in production. When you deploy this into our serverless environment or even in Kubernetes, SpringCloud GCP will also automatically detect the credentials associated to that environment. Okay, and I will show this later as well. Okay, cool. So now everything's up and running. I am going to go ahead. Yep, go ahead.
Sorry about that. You were actually. My question is about the. How can I say that? Is about mostly a legacy application or any app that, or any system I would say that we are going basically into transferred into cloud. So most of them are not as easy as what basically demonstrated here now, like a Hello World style. So from the Spring Boot point of view, I didn't see much difference except that, okay, you know what, there are a little bit of syntax is different and they're in the same layer. But the concern is that though, there are two things here. First of all, in, let's say, mostly in financials, right? There are two systems running in parallel. So let's say A and B, regardless, okay?
Okay.
So A and B are working and B basically 100% replicate A and are the same. It's just in any kind of condition that, you know, something is wrong. Anyways, they switch it from one to the other. That was one thing that how that is working here in a cloud. The second one is, that was my question that came. Is there any way that it still can have the old Spring Boot style microservice at some point, taking advantage of the database, let's say not to have a database and get it from cloud, but it still stay with that legacy, because those apps takes a long time that you want to basically change it, refactor it, and put it this way to go with, let's say, new Spring. And the one that works with the Google. So how do you basically bring up the solution with two questions that I had? Thank you.
Yep. So I think that's pretty involved. And to do that, it requires a little bit more architecture around the application itself, right? It's not that the application itself can just produce that, right? But remember though, there are a lot of patterns and paradigms that Spring Boot does support. And it also goes back to how old is your existing Spring applications, right? Or even maybe they're not Spring, maybe they are Java EE applications, right?
No, my
And
question, let's say straight to the point. Let's say I have the latest Spring Boot app is running,
yeah,
and now I'm gonna integrate that with Google Cloud, but I don't want to have so many changes. So let's say I don't want to have
exactly.
1 year, but I want to take advantage of a database for now, and then
Yep.
little by little shift it. You know what I'm
Exactly. Yep.
saying?
Yep.
That was my question. Yeah.
So for that, first of all, it's like, what database do you want to switch to?
For instance, that you mentioned.
Right. Yeah. So what database do you want to switch to? And based on the database that you want to use, potentially you can start adding the Spring Data integration with that, so that it's not so foreign, right? It's not completely different from what you already have. In fact, you can have multiple Spring Data implementations working together. So you can keep your existing Spring Data repositories, and then you can start adding new repositories to your application as well. So imagine the person repository, you actually have two of them. One of them works with the data store repository, the other one works with the JPA repository. And now you have two repositories that you can work with. Okay, so right. And then you can slowly refactor the code so that the old repository code, like your business logic code, is going to start adapting the new one. And because that we implemented pretty much the same API, if your repository code is fairly similar, then ideally you can limit the blast radius that you have to change at in the middle layer, in the serverless layer. Yeah.
Arash, let's leave the questions for Q&A. So for people who are first time on a meetup, let's give us present opportunity to walk through this presentation, write down the questions. I am already starting to write mine. And then at the end, we can do that. So people watching the tutorial can ignore Q&A. It's going to be hard to watch afterwards on YouTube. Yeah. And I'm recording this, so just let you know. Go ahead.
Okay. Yeah, cool. Yeah, thank you. Yeah, and maybe for some of the more involved questions, we can keep it to later as well. But then if this is in context, then maybe I can answer in line too. So please keep some of the questions coming as well. Yeah, cool. All right. So now, let's see, where was I? I'm going to go back to the person repository here, and I'm going to just go ahead and run this request. And here we go. We got hello Ray, and here's my ID. And if I come back to my data store, just to show you that this is not fake, because sometimes people say, well, the data was there already. But no, it's actually just being created just now. Okay. Now, the next part of it is, of course, if you want to add messaging to your application, if you want to have microservices application where you want to buffer your requests, you don't want everything to hammer your application all at the same time. You need to send some of the processing to your backend so you can buffer them and process them out of band or asynchronously, like sending an email or something like that. In which case, you can just create a message. You can use messaging system for doing that, right? And again, in the past, we may be using very heavy-duty GMS messaging system behind the scenes. For most purposes, what you really want is just a pops-up system where you can publish the message, and you want to have somebody on the receiving end to be able to process it. Okay, and to do that, I'm going to jump down here. On Google Cloud, we have what we call pops-up. Nicely named for publish and subscribe. It's a one-to-many messaging system. One of the things that not many people know about PubSub is that it's actually globally distributed. What that means is that with a click of a button, without any setup, without any configuration on the server, you have a globally available distributed messaging system that you are ready to send messages to and ready to receive messages from. And it has at least once delivery guarantee, but also additional things like ordering and filtering. Now, the last two of these features are really important, especially in potentially CQRS workload, or even in data replication or data change capture workload, like what Arash was saying, so that you can capture your events in order, and you can filter out the events that you really care about. Ordering in this case is really, really important in a way, and we can do that for you behind the scenes too. Again, there's nothing you have to manage behind the scenes. Okay, so you can produce a message, you can send it to a topic, and every topic can have multiple subscriptions, and each subscription can have multiple consumers. Okay, so what that means is that when your message is sent to the topic, it's replicated across multiple subscriptions. And then for one of the subscription, maybe you have multiple consumers that's processing messages in parallel. So each of those consumers will only get one of these messages. So the messages is only replicated to the subscription, but they are competing. These consumers are competing to get the messages behind the scenes. Okay. However, remember the guarantee is at least once, so it's not once and only once. So what that also means is that you may actually get duplicated messages, in which case you have to do some deduplication if that's important for you. Okay. So in SpringCloud GCP, you can have a couple ways of doing it. I'm going to show one of the easier way for now. And then we'll talk about Spring integration maybe later. But if you're using Spring integration, we can tie into the pipeline. What that also means is that it's fully integrated with SpringCloud Stream as well. But if you just want to get started, what you can do, of course, is to add a starter right here. So there's a PubSub starter, auto configuration. Just by doing this, we would automatically configure this project with PubSub for you. What that means is that because we're not using Spring integration right now, so what that means is that we can use a template, just like you have like the RabbitMQ templates, you have the ActiveMQ templates, or JMS templates. In this case, we have a PubSub template you can use. So I'm going to say PubSub template. PubSub. Let's do the publisher template. Publisher template. It's there. This, but interestingly, it's not showing up. PubSub. Sorry. Publisher. Template. Yeah. All right. So maybe I need to type it out myself here. PubSub. Publisher. Template. Sometimes the auto import doesn't work. Yeah. There we go. Okay. So with the publisher template, let's say I have received a request, then I'm just gonna publish it. Now I can go back to the console, and let's go ahead and find PubSub. Okay, and I'm going to create a new topic, and I'm going to call this a serverless PO topic, and that's pretty much it. So just like that, I have created a globally available topic, and now I can send messages to it. So I can here sending the payload, and the name is let's say saved, something like that. Okay, and let's just leave that down for now. Okay, and that's it. That's all we need to do to be able to publish the message to a topic. Now to receive it, we have to create a subscription. So here we can go ahead and create a subscription, and then maybe this is called serverless PO subscription, something like that. It's easily misspelled, so I'm gonna make a copy of it. Now for the subscription, we can have different ways to deliver the message. You can pull the message, or you can push. When you push the message, what that means is that it's going to push to a webhook. So you can push it over HTTP. But for us, we're going to use a client to connect to the messaging system, in which case we're going to be doing pull. The messages can be retained as well, so that you can keep the message. If nobody pulls the message, if nobody consumes the message, then we can retain the message for up to a number of days of your choosing here. Okay. Sometimes maybe it's not so important to retain the message, even if it's not processed. Then you can reduce the retention period here. Okay. And if the subscription is being unused, if nobody ever subscribed to the subscription, we can automatically expire. So we can garbage collect your subscriptions as well. If nobody ever uses a subscription, maybe it doesn't really need to be there, so we can expire it. Or you can say never expire, and so on and so forth. Right? And the other thing, I think, in addition to ordering, the other thing that's pretty important is data queuing. So if the message has been on the topic or subscription for repeatable times, then if all the retry has failed, then we can then send it to a dead letter queue instead, or dead letter topic instead. Okay, so I'm gonna go ahead and create this too. Now to consume the message, again, you can consume it from Spring integration, you can consume it from Spring data flow or SpringCloud Stream. What I'm going to do is to just consume it from a very simple subscriber as well. So for this one, I'm going to use Java. I'm going to just add maybe with Flux and add GCP messaging, right? That's the starter that we can have. And this is a subscriber. Okay, I'm going to go ahead and generate, open, right here. And now we have a subscription project that we can use. Okay, and because we generated the application with messaging in there already, if you go down, you can see the starter. We already added the auto configuration, and it's going to also use the same credential as what we use for data store. Like it's going to automatically discover the credential. Now I can go ahead and create a little command line here using command line runner. And I can start listening for messages, for example. So for example, here I can say, here we have arguments. Let me zoom in just a little bit. And I am going to use, maybe I can try to use the reactive subscriber. So here we have pops up React factory. So I can subscribe to our messages in a reactive way. Basically, what that means is I can use the reactive message factory, and I can poll my subscription, which I hope I have copy and pasted. And maybe I'm gonna do the polling every 1 second. And now I'm dropped into the reactive API. This is all Flux API. Okay, so I can say map each of the incoming message. And all I'm going to do is going to print it out. Print out the message here, message dot get the message, get data dot to UTF string, so I can print it out. Okay, and then I need to acknowledge the message. This is pretty important in Google Cloud pops up. If you don't acknowledge the message, then it will be redelivered. And if you have dead letter topic, then after certain retries of redelivery, then it's going to be sent to the dead letter topic instead. Okay, so in this case, once this is done, I'm going to ack it. And because I'm using app, then I can return the ack here. And then you can do additional processing of the acknowledgement if you want to. And in the end, I can subscribe. And that's pretty much it. Now I have a reactive poller that can listen to my pops up messages. And all I need to do is to run it. Okay. So for example, here I'm going to say server port is 8081, so it's not conflicting with the other port. And let's see if this works. I'll be pretty happy if we can get this part working as well. All right. So here we have the poller up and running. Just watch for the message on the left-hand side as we send new messages over. And where's my other thing right here? Okay, so this is my other application, which I'm going to restart. Okay, so now in addition to saving data, we're going to also publish data. Okay, and then I'm going to do a test here. So I'm gonna run this test again. Okay. So here I sent the message out, and hopefully here I have received it. So that's pretty cool. In fact, that wasn't so impressive. I'm going to try this again, and I'm going to use Daniel's name here. Hello, Daniel. And I'm gonna try to do the same thing, and watch how the message will show up on the right-hand side, just like that. Again, all without any stuff to maintain. I think this is really the premise of cloud, to be honest. The velocity of how fast you can get some of these things done is absolutely amazing in the cloud using some of these services. All right, so one more thing I want to show is just being able to add some trace and monitoring capabilities. Again, all of these things are using standard Spring Boot APIs. So for monitoring, you can use Micrometer, and we can start sending all the QPS, all the metrics to cloud monitoring. For traces, for example, if you have a microservices and you need to capture the trace, all you need to do is to add, you can either use SpringCloud Sleuth, or you can add our starter here, which is SpringCloud GCP starter for trace. I'm going to add logging capability here too, so we can send stuff into centralized logger. Okay, and when these two things work together, to me, it's pretty magical. What that means is you can see the trace, but you can also see the logs correlated to your request within context. And using the Spring Boot integrations, we make this task really, really simple and straightforward to implement. So let me show you how this is done. So for trace, this is all it takes. Okay, so adding this auto configuration, we already are going to use SpringCloud Sleuth to capture all the traces for you. Any incoming requests will be traced, and we'll also propagate the trace information down to the next call. What do I mean by that? Let's implement another method here, call all. And this is just going to simulate a microservice calling another. So this is going to use a REST template. When I call this endpoint, it's going to call itself, right, multiple times, and the trace information will be propagated from the original call down to the nested call down here. Okay, and for this, I do need a REST template, so I'm going to go ahead and make that a bin. So let me just go ahead and create REST template. In and from REST template is equal to REST template. It's just a shorthand for Kotlin to do a return. So rather than return new REST template, I can just do an equal, almost like a functional way. Okay, and then I can go ahead and inject the REST template here. Okay, now I can make a call to all. Okay, and remember what this is going to do is going to propagate the trace information. Now, one more thing I want to show you is the logger. So here we're logging something, right? We're actually logging this particular event into the log message. What I also want to do is to send this log message to a centralized logger. If you're running on Google Cloud, this message will be sent to the centralized logger out of the box. Okay, so if you're running in a serverless environment like AppEngine or CloudRun, or even in Kubernetes engine, whatever that you output into the log will be produced and saved into the centralized logger. But I want to go a step further. I want to have structured logs. I want to have logs that have additional metadata. Okay, so in this case, I do need to configure the logger slightly differently. So unfortunately, this requires some additional configuration. So in this case, I can add a logback configuration. And maybe I'm running somewhere else, like right now I'm running on my computer. So I want to send a log to Stackdriver via the API. So by adding this configuration, your logback is going to be able to produce the log message, not only to the console, but also streaming it to the Stackdriver API behind the scenes to our service. So now you can send your log and ship your log to our centralized logger. If you are running within Kubernetes, then what you want to use is the JSON format. Okay, so rather than producing the JSON format yourself, which by the way is really, really difficult to find documentation for it, in SpringCloud GCP, we encoded the JSON format that will work with Kubernetes engine and all of our serverless products so that you can produce these JSON logs in the right format with the right metadata as well. But for the demo right now, I'm just going to go ahead and use the API console logging for now. Okay. So remember what I've just done? I added trace and I added logging. And the metadata for the trace is going to go into the log itself as well. One last thing before the demo is that by default, Spring will trace only 10% of the request. Okay, so for a demo, right, I have to hit the endpoint 10 times for me to be reasonably sure that I have a trace. But in this case, for the demo, we're going to up it to 100%. So supposedly 100% of the request will result in a trace. Okay, so that should be pretty awesome. And let me go ahead and rerun this application again. I'm going to re-request the endpoint with the test HTTP. Okay, and rather than calling hello to a single person, now I'm going to say hello to all. So let's see if this is going to run. Okay, so hello all. It's ran. If I come back to run, you can see now I've said hello to 3 different people. Myself, Mandy, one of the person I work with, and Jisha, she also worked on SpringCloud GCP as in the past. But now look at the log messages. The log messages actually now have the metadata, right? We have the trace ID and the span ID. So this is what ties everything together for the log messages to correlate to a single trace. The last attribute here is true. That means that the trace was sampled. What that means is that it's actually being stored in the tracing store behind the scenes. So it's actually being sent to us to Stackdriver or to CloudTrace behind the scenes. Right. Now, of course, because we're also sending out messages, we can see in our subscriber, we have the 3 messages arriving as well, which is all working so far. And now, I think what I can do is to go to my application, go to my Cloud Console, and let's go ahead and see if I can find this trace. Okay, so I can go to the trace list. Again, there's no application, there's like no zipcon or anything I'm running behind the scenes. And this is just pure, just service that you can utilize. And now I can see the trace here. You can see the request I just made. I can click into it. And I can see all the span that's associated with my application. Right? You can see the initial hello all and each of the call. Okay. And what's the best thing about this is you can also click on this thing called show logs. Okay. So if you click on that, you can see in context with each of the traces, okay, you can actually see the message associated with that particular request. So as the messages come in, because this is a little asynchronous, the message is going to be showing up right next to the actual request. So here, as we code hello Jisha, you can see the message, the log message that's produced right next to it as well. If you want to dig even deeper, you can go into the log viewer, and then you can use the trace ID to find more messages that's correlated to that particular request as well. And this works both for synchronous calls and also asynchronous calls over PubSub. Okay, so if you're using Spring integration with PubSub and you send an asynchronous message and then you process the message maybe 5 minutes later, they will all have the same trace ID and they will all show up in the same graph, and you can all see the same log messages across the same trace. Okay, and that's something you just get out of the box, which is pretty neat. All right, so I'm gonna stop here to see if there are any questions, and then check in on the time to see if there are more things you may want to see around SpringCloud GCP. Okay, so got a question here with Sandeep. How easy is it to use hybrid Kafka and PubSub on GCP? Will this hybrid be totally serverless? So you can use Kafka with PubSub if you want to. Or in some cases, some people bridge PubSub into Kafka or vice versa. So for example, if you have a on-premise system that's using Kafka, you can actually have a Kafka subscriber that bridges the message and send it to PubSub, and then you can shift that message to the cloud if you want to. And you can do it in the reverse as well. Or your application can actually use both Kafka and PubSub at the same time if you want to. For Kafka, it's not exactly completely serverless, but we do have partnership with Confluent so that you can use Confluent Cloud so that you have a fully managed Kafka instance if you need to. So you can have fully managed Kafka instance plus a fully serverless PubSub messaging system behind the scenes.
Okay, got it.
Yep.
I had one more question. Like the cloud that you are using, is it like a reactive or it's still a blocking one?
Which one? The
cloud store, the database that you use, right?
Right. Okay, yeah, very good question. So data store is not reactive. We're working on a lot of the reactive stuff as we speak. They are something that is reactive. So for Spanner, we have R2DBC driver for Spanner. Okay, so that can tie into Spring Data reactive feature. For Firestore, Firestore is fully reactive behind the scenes. Firestore can actually, it's breached into the reactive Spring data behind the scenes. So if you want fully reactive database, you can use Firestore. Otherwise, you can use Cloud SQL with R2DBC drivers for PostgreSQL or for MySQL database behind the scenes. Yeah.
Okay. Thank you.
Yeah. Very cool. All right. And for messaging, as you saw, a receiver can be fully reactive, and the rest of it you can tie it into SpringCloud Stream, which also is reactive as well. Okay. Any other questions before I maybe deploy this application somewhere? Yeah?
Keep going.
Right.
We do have enough time.
Okay, very cool. Oh, one more question from Sanchit. Suppose I have legacy RDBMS and want to migrate it to NoSQL. Then is it possible to do parallel running? I think it's very similar to what Arash was asking. And the answer is yes, but that is not something within the control of SpringCloud GCP, right? It's actually your architecture of your application. And there are many, many different ways of doing this. Why don't we go back to the same question later as well to go in more depth, because that will involve, potentially like a load balancer, a ESTO, or data change capture and stuff like that. So it can be very, very involved. Yeah. But in the meantime, just remember, if you really want to, you can use multiple databases within the same application, of course, and potentially tie the transaction across two resources at best in our case, because we don't support XA transactions, in case you're wondering. Yeah. So you can do similar. You can simulate XA across two resources or one resource that's not XA. Okay. All right. So let's go ahead and I'm going to do something pretty unprepared in this case. What I'm going to do is to show you how to deploy this into CloudRun, into a serverless runtime environment. Okay. So what I'm going to do first is to do a git init, and I'm going to commit my code initial. And then I'm going to publish this on GitHub. Okay, so I'm going to publish this repository onto GitHub. So I'm going to code this serverless demo. I'm going to keep all the code public so you can see it too. It will go onto my GitHub under my username, which is Satanism. Okay, so I should have checked git ignore, to be honest, but too late. I hope I didn't commit too many things. All right, so then I'm going to go ahead and deploy into CloudRun. Now, what did I actually check in the code first before I deploy to CloudRun? Well, in CloudRun, not only can you deploy a container, so I can, of course, go ahead and containerize my application. In fact, there's a really nice utility that we wrote, right? Google Cloud wrote, which is called Jib. So if you want, you can create your container using Jib really, really quickly. In the newer version of Spring Boot, you can also use the build pack. But why did I just go ahead and check in the code? Well, that is because in CloudRun, I can actually just configure my CI/CD pipeline directly from there, which is really, really cool. So remember that diagram which I showed? Like, it's not just the surrounding applications, it's not just your runtime environment, but also your CI/CD pipeline as well. This is pretty much almost the epitome of what I was looking for a platform, right? So what I can do is go ahead and create a new service. I'm going to code this the serverless TO service for the lack of better name. And then rather than deploying a pre-existing container image, I'm going to go ahead and configure continuous deploy. Okay. And to do this, I can set up Cloud Build, and I'm already authenticated with my GitHub repository. And now it's searching my repository for everything I have. There's a lot of stuff in there. So it's going to take a little time. But once it catalog all my repositories, I can go ahead and find the one I just published. And now it's going to tie up the CI/CD pipeline to build my application, build the container image, and then push it to CloudRun automatically. Okay. So let me go ahead and find this. Here's my serverless TO demo. Okay. And next. Okay, so now it's setting up the CI/CD pipeline behind the scenes. I think GitHub has defaulted all the main branch to code main, so that's what we need to do. And down here, If you have a Docker file, we can use the Docker file directly. If you don't have a Docker file, we have what we call the Google Cloud build packs. So this is based on the cloud native build packs, and the build pack can automatically detect your source code and know that this is a Java application, and then produce the container image behind the scenes. And that's all you have to do. So in a single click here, I have tied up a CI/CD pipeline that can introspect my source code, build it, the application, and then produce the container image, and then pushing it to CloudRun. Okay. And let's see, there's another setting I want to add here. In CloudRun, my application is listening on port 8080, so I can configure that. Right? I can configure all the environmental variables and configurations. But moreover, it is a Java application after all. So I'm going to give it a little bit more memory. Okay, you can, depending on your application, you can give it like 1 GB or 512. 128 is probably too little. You can go up to 8 GB at the moment. For the demo, I want it to be fast, so I'm going to use 4 GB. I'm going to give it 4 CPUs as well, something that's really, really fast. Okay. And auto scaling here, I can say, hey, I want to have a minimum of 1 instance. If you don't care, then you can scale down to 0 if you want to. I'm going to say a minimum of 1. So I will always have 1 instance running that's ready to receive the request. Okay. And finally, I will use a public gateway here. So I'm going to allow all traffic, and this is actually HTTPS. It's not just regular HTTP. I'm going to allow anyone to be able to call it. Okay. If you are developing something internal, then you can allow internal traffic only. This is really, really cool. This is actually pretty new. They just came out just before the New Year's, if I recall correctly. Okay, so I'm going to go ahead and create this. And what this will do, remember, is to create a CI/CD pipeline behind the scenes, hook it out to my source code. It's going to trigger the build my application, build the container image behind the scenes, deploy to CloudRun, do the rolling updates, and whenever I check in new code, it will do the deployment for me automatically. And that is pretty cool in my mind. Okay, it will take a couple of minutes for this to show up. So while we wait, I'm going to show you another thing you can potentially do. Okay, because on Google Cloud, we have 3 different serverless environments. We have CloudRun, which is container image friendly. We have AppEngine, which can actually just run your application without a container image. What do I mean by that? What I mean is that here we have a target. Let me go ahead and build my application. A lot of people, when we do Spring Boot applications, we like to build a jar file, right? We like to build a jar file. So I'm going to go ahead and build a jar file, and we can use AppEngine to deploy the jar file very, very straightforwardly. Okay. In fact, did I not say skip tests? Skip tests. Yeah, something like that. Okay. So this will take a little time. So I'm crossing my fingers that this will work. Yeah, maybe it's already finished. I'm going to find out pretty soon. Okay. But in AppEngine, this is what we do. In AppEngine, we can say something like, we need to create a new descriptor here. So I can say YAML. And I can say the runtime is Java 11. We need to tell it, because it doesn't do auto detection for us, so we need to tell it this is a Java application. And just like for CloudRun, we need to increase the instance size. Here we can say the instance class is a little bit bigger. I'm going to say this is F4. So this has 2 GB of memory. And then I can just use gcloud app deploy my jar file, which is right here, using the configuration app.yaml that I just created. And this will deploy your Java application into AppEngine instead. Okay, and that's all it takes. So if you have a jar file, you can just do gcloud app deploy a jar file, and behind the scenes, we'll spin up all the servers for you. We'll do auto scaling for you, and that's it. That's really straightforward. Between AppEngine and CloudRun, they are both very comparable in terms of features. If you're running into, especially if you're moving to containers, I would say use CloudRun to start with. But if you are just using Java applications, AppEngine is definitely easy too, because you don't have to deal with containers at all. The third environment is our function. So that's the Google Cloud Function. And for Google Cloud Function, you can deploy with our own API, or you can use Spring Cloud Functions as well. And you can write a Spring Boot application using Spring Cloud Functions, and you can deploy that into Google Cloud Functions. I happen to also be part of the Google Cloud Functions team as well to deploy, create the Java 11 function stuff recently. Okay, cool. So this, you can see like the build actually, I think, just finished. So now it's deploying a new revision right now. So as soon as the revision is deployed, we may actually be able to see this application up and running. And that would be really, really cool. In the meantime, I'm going to see if there are any other questions right now. Sandeep has a question. Is there blue-green deployment on GCP? Yes. So this is one of the, by GCP, I'm going to narrow this into CloudRun and AppEngine. So yes, there's you can do blue-green deployment in both of these environments. In AppEngine, let me show you what I just deployed. Okay, so here's my AppEngine service. As you can see, I actually have 9 different versions. Okay, I actually have different versions of AppEngine running right now, of my application running. And in fact, what you can do is you can go back to any of the previous version if you want to. So let's say, this version that's running right now is not very good. You can say, let's go back and migrate my traffic back to the older version. You can also test any one of these versions independently from each other. So if I click open both of these links, let's see, that's the default. And this one, you can see this has a version unique URL. So this is how you can do blue-green deployment. You have something that's already running, and you deploy something that's new, and then you can test that new URL before you shift the traffic to the new version. Okay. And similarly, you can also split traffic between the two. So here you can do traffic splitting. Okay. So between the two versions, you can say, the old version is going to take 80% of the request, and the new version is going to have 20% of the request. And over time, you can increase the traffic split to 100% if you want to. This is all built into the platform, by the way. And you can do the same thing with CloudRun too. So in CloudRun, they also have the managed traffic capability here. So with the 2 different CloudRun application versions, you can specify the traffic split between the 2. Okay, so I'm going to stop there for now, and hopefully this application comes up. Any other questions before I embarrass myself where the application doesn't work?
You cannot embarrass yourself. This is amazing. It shows agility, everything.
Yeah, so let's try. So AppEngine is up and running. So maybe it's running. We'll see. Oh, it works. So you saw that I just created the application from scratch. Use some of the services that we have using Spring Boot with the APIs. That's not foreign, right? And I just deployed this into AppEngine using gcloud app deploy a jar file, and this is automatically scaled behind the scene for you. That's pretty cool with HTTPS endpoint, with traffic splitting and trace and logging and all of that good stuff. And hopefully, eventually, the CloudRun stuff will start too. And then we can see the same thing, exactly the same thing on CloudRun as well. All right. Let's see. Danny has a question. What does allow internal traffic only option in CloudRun means? So let me go back to the deployment here. That's a very good question. So let's say test. And setting. Well, let's see what I have here. As you can see, you can deploy literally any container image that you have. So I'm going to deploy that one. Okay. Okay, and let's see. Here we go. So this is the thing that you're interested in. So allow all traffic means that it is going to be open on the public internet. And then when you hit this URL, you can hit the URL from anywhere in the world. When you have allow internal traffic from cloud load balancing, that means that you can front your application with our load balancer. Okay, so you can front it with an additional HTTP load balancer. And the reason why you want to do that is because CloudRun is regional. So when you deploy this application, it's deployed into a region. Okay, and the region, what I've chosen is US Central 1, right? But what if you want to deploy a global application? What if you need to deploy your application in the US and also in Europe, for example? You can deploy 2 different services, but then you need a single load balancer to load balancing between the 2. And so for that, you need to put our HTTP global load balancer in front, right? So in that case, you don't want people to go to your regional application directly. Then you can choose this one, which is to say it's internal traffic only, and only from the load balancer. Now, the question was this one, which is allow internal traffic only. What this means is that you can only receive requests, not from the public internet, but only receive the request from your local VPC. Okay, so if you have a VPC, every project has VPC set up, so you can have your corporate VPC that's being configured to be able to call this service, and you don't have to worry about the internet DDoSing your service behind the scenes or something like that. Okay, so this really just means that you can make the call to your application from within the VPC and only from the VPC. Okay, and then authentication option here is that if you want to secure your services with Google Cloud IAM, then you can require authentication here, and we will secure the services for you behind the scenes. You don't actually have to write your own authentication if you don't want to. Okay, very cool. So let's see if the CloudRun service starts. Maybe it doesn't start, and then that's too bad. Any other questions while we maybe wait for it, or maybe not? Oh no, it failed. Of course, something has to fail. Oh, interesting. This basically means that the application may not have started properly. So actually, while we're at it, we can also see that down here, we can see all the logs. So we can actually see why this application didn't start, right? So this is pretty cool. Remember that centralized logger? It's all here. And I can go in here and see in more detail. So I'm gonna pop open the actual log centralized logger here. And maybe we can see some error messages somewhere that's going to tell you where it actually failed. Okay. Any other questions in the meantime? One more last thing that I want to see is let me go back to my slides real quick. Where's my slide? There it is. A lot of things I didn't get to show. One of them is cloud storage, which is a way to store as much binary object as you want. So you can store photos and videos, all the cat videos that you ever want to serve, you can put it into cloud storage, right? The other thing is secret manager. This is probably more relevant for an enterprise application as well. Again, if you want to securely store like credentials, like passwords and stuff, you might want to put that in Vault, right? On-prem application. But on the cloud, you can use secret manager, and this is our secret store. It's fully encrypted behind the scenes. You can even bring your own encryption key if you want to. And we have a SpringCloud integration behind the scenes with this too, so that you can use the standard Spring annotations and Spring expressions to actually refer to the secret. So in case you create a secret called secret password, you can just refer to it with $sign and the curly braces prefix with SM for secret manager, and then reference to the secret name itself, and that's it. And then the secret will be injected into your application automatically, which is pretty cool. Okay. And in some cases, maybe you want to access a secret from another project. You can expand this expression to point to a specific project if you want to. The secret is also version 2, so you can actually have multiple versions of your secret, so you can do secret rotation if you need to. Okay. Nice. So that being said, are there any other questions? Hopefully this was useful for you to see what the Spring Cloud GCP can do with Spring Boot, and a quick view of AppEngine and CloudRun.
It's awesome. Thank you.
Yeah, thank you.
Thank you.
Yeah.
So I had one question, Ray.
Go for it.
Can you hear me? Yeah. So suppose you have a service on Google Cloud. So for example, any service registry like console or any configuration server. Okay. And on your application side, okay, just by putting the Spring Cloud Starter console dependency, will everything work, or is there any extra configuration that is needed so that your application exactly knows what console it is and all those things?
Gotcha. Yeah. So this is a Spring Boot application, right? If it is a Spring Boot application, first thing you need to know is the version of Spring Boot. Okay.
Right.
And then, because every different version, minor version of Spring Boot has a different comparable version of Spring Cloud. Okay, so in 2.3 you can use Hoxton. In 2.1 you have to use something else. But as long as you're using the compatible version of Spring Cloud, then it's all the same. Exactly what I've done can be done with any Spring Boot application out there today.
So if I just put a Spring Cloud Starter console dependency over here, and if on the Google Cloud that you connected to is having the console service, like any service registry service, so it should work, right? There is no other configuration that is needed.
Right, but we don't have a console integration in this case. So for example, right, yeah. So but let's say you're using trace in your Spring Boot application, just add this configuration, then the trace will be automatically configured. However, we do not have console integration specifically, right?
So
But
what solution Google has for the service registry, or maybe Vault or anything?
yeah, so for service registry, that's pretty interesting. It depends on your use case. And so for example, if you're using CloudRun, then there's no need to use a service registry in this case, because it's automatically load balanced at the endpoint. So rather than hitting your CloudRun service or your AppEngine service by the actual instance ID, it's already load balanced behind the scenes. So this is your name that you use, and you do not need to keep track of all the backends behind the scenes. Does that make sense? Same thing with CloudRun. In Kubernetes specifically, you potentially also do not need a dedicated service registry because Kubernetes itself has the service registry, and you can do service discovery directly within Kubernetes as well. That being said, if you absolutely need to use a service registry, in particular for, say, spanning and routing traffic globally, one thing that you might be able to look into is called Traffic Director. Okay, and it is using something called the XDS protocol. I'm gonna type in the chat for service discovery, and this is the same protocol that Envoy or Istio uses behind the scenes. Okay, so it's a different protocol, right? Console and Eureka, they have their own protocol for discovering the services. For Traffic Director, it uses XDS.
Okay.
Yeah.
Okay. And just the last question, like for externalizing the configuration, right? So we use the normal Spring configuration server. So it can be directly used on Google Cloud as a service, so that we can, like, suppose if there are 2 or 3 configurations that are changing, I don't need to deploy my entire code. I can just refresh the endpoint on my service and get the updated configurations, right? So it will directly work as it is on Google Cloud also, right?
Yeah, so we do not have the hosted Spring Cloud config server, right? So, but those configuration can be offloaded to, say, Secret Manager, for example. So if you use Secret Manager, then you can put these metadata configuration into Secret Manager, and then you can get that directly from Spring Cloud config. We also have something called the runtime config API. Unfortunately, I don't recommend anyone using that right now. Because I think a Secret Manager is probably slightly better. And also, this is gonna be a little out of the ways, but potentially using something like Firestore to store those metadata. That's another pattern that other people have done. Yeah, but we do not have a hosted config server like that for Spring.
Thank you so much. Yeah.
Yeah. Okay, so another question. The major difference between CloudRun and AppEngine is that CloudRun will have the content image and will be deployed to the server, while AppEngine image are not created. Am I getting it right? Almost. So CloudRun, let me actually go to the bottom of this. I think this last slide is probably the best way to differentiate between the two. To me, the primary difference is the deployable artifact. So in AppEngine, you can deploy a jar or just the source code. In CloudRun, because it will build it behind the scenes. In CloudRun, it will deploy your container image. However, if you tied it up with the CI/CD pipeline, then it's going to be able to deploy from source into container image. Okay. Their billing units are slightly different. So AppEngine, when I trigger a request, it scales the application up to one instance. It doesn't matter if I'm getting more requests. As long as the instance is up and running, I'm getting charged by it. It's being billed. And it will automatically shut down after 20 minutes. If there's no more request, it will shut down. But you're going to be billed for a minimum duration of that application instance. Okay. In CloudRun, the billable thing is the time that it took to process your request. And this is a little complicated, actually. So they actually have a chart, a diagram that makes it a little bit better. So I'm gonna pull out the diagram directly. By billable time, this is actually the amount of time that your application is actually running. Okay. So another really important difference here is that in AppEngine, your instance when it's up, the CPU is always available when the instance is up and running before it's shut down. In CloudRun, your CPU is only usable when you are processing a request. Okay, what that means is that when the request comes in, when you have a HTTP GET or a POST, that's going to allocate CPU time for your application to respond. And then when your application responded, and if there's no more request, then your application do not get more CPU. Okay, so you're only being charged by how much CPU time you actually were using. Okay, and this may actually help with reducing the cost, right? Because this is basically you're being charged for the CPU time that you're using, as opposed to the instance hours that you're using. Okay.
Hi, Ray. Sanchit this side. So we can basically say that from the first request that is being sent to the server to the last response that the server sends,
That's right.
That's the billable time in CloudRun, right?
That's correct. Yeah.
And we can also say that CloudRun is an advanced version of AppEngine, or is it totally differently like developed?
I would say they're different. Is it advanced? I think it's getting there. Yeah, definitely. It's pretty new, and I think that it has a little bit more velocity in terms of the feature development, right? At the beginning, I think AppEngine has a lot more feature than CloudRun, right? Just because CloudRun is really new. But with the recent additions, as you saw, like with the CI/CD pipeline, with the traffic splitting and all of that, CloudRun is actually getting really good as well. So, and the innovation will continue as well.
Maybe I can add something. Satish, we did have a meetup on the topic with Kelsey Hightower. So go back on YouTube or SlideX and watch that. And also you can buy this book. This is a brand new book. It's becoming Bible for CloudRun. Now,
yeah, sure, Daniel. Thanks.
It's opposed to containers, like it's simplification of Kubernetes. It's bridging the gap between serverless and containers. AppEngine is a PaaS platform. They did have a Flex version, but standard is a PaaS like I don't know, Heroku, like PCF. So CloudRun is bridge between the two, I believe.
Yeah, thanks. Actually, I'm a bit new with cloud, so I'm asking some silly questions.
No, they're not silly at all. Like lots of people are confused. That's why we have Ray here to simplify, to show you. Being a Java developer, you are more cloud native than you think. And you see how for him, even if you're not coding that fast, still you can achieve way more agility and impressive results. So that's
Yes.
I was about to ask you to go back to the slide to wrap it
Yeah.
Daniel,
Okay, thanks.
up. Go ahead.
and then it just you mentioned that CloudRun is bridging the gap between the uh, uh, between Kubernetes and so basically between the image serverless and the image base. So can you explain once again how?
So with serverless, you don't manage anything. Like it's completely up to the cloud vendor to scale functions.
Mhm.
With containers, like with Kubernetes, it's orchestration engine for orchestrating containers. So there is a initiative, Knative initiative, that CloudRun is a product of, Google version of, that simplifies managing containers. So you just give it a Docker image, and it does the magic behind the scene. It scales like Ray showed. So Google went even further. They wrote the function framework that is kind of within the CloudRun. So your function is really becoming mini containers. So
Okay.
it's same technology behind the two. You just don't worry about managing servers.
Got it.
In fact, AppEngine actually builds the container for you behind the scenes too. Yeah.
Okay, that's cool.
So, yeah. But at the end of the day, though, this is what I would say: your application has the same needs, regardless of where they run, regardless whether it's PaaS or container or Kubernetes. Because I've done several Kubernetes implementations, and we always end up implementing the same thing. And these are the needs, right? A way to receive request, a way to tie it to a domain name, a way to do URL mapping as gateway, a way to traffic split and do blue-green deployment, right? A way to gatekeep, who can actually make the call, and a way to auto scale. The same pattern is the same across whatever runtime environment that you encounter, right? Heroku had the same thing. AppEngine had the same thing. PCF may have had the same thing. CloudRun is having the same thing. And if you implement your Kubernetes, you eventually end up with the same thing. I guess that's what I'm trying to say. But in the serverless world, you can get there right now, and you get all of these capabilities out of the box very, very quickly.
So to add to that, I believe that the laws of nature apply here. Like water always goes around the obstacles. So the simpler solution, the better it is. So always choose. There are so many technologies. I was always choose simplicity over complexity and less management.
Yeah. Well, it's too bad my CI/CD pipeline failed, but I'm not gonna spend the time to troubleshoot this one. But if it actually ran, there are a few other things you might be able to see, like you can see a dashboard with the traffic. In fact, you can see that in AppEngine 2. You can see the traffic in the graph. You can see QPS. You can see the basic things that you definitely want. And then for your application metrics, you can send more if you need to.
I think it said it failed to bind the TCP port from your environment settings, but you're right. It's not important. We don't need to debug it, but I think I saw that message.
Yeah, but it's sometimes misleading. Sometimes it just means your application, the application did not start.
I see that's a symptom of a bigger, a different thing. I get it.
Yeah, but that's weird. I'm pretty sure I tried it before, but whatever. That's too bad. Yeah. Oh, but I do have another version up and running. You know what? So this version, when I tested it before, that one. So this one is pretty much the similar app. And it is also built from a CI/CD pipeline, and it's almost exactly the same app. But here you can see some of the basic graphs you can get in the metrics you can get: request count, latency. This is your billable instance time. So remember that what we talk about, the first request to the last response, CPU utilization, and container memory utilization. It's all out of the box. And logs, right? So if you want to see centralized logs, this is where you see it. I think these are probably two of the most important ones. And then you have the trace, which I showed you earlier. All of that just work as is. Yep.
That's really neat. You showed in the pipeline, the build pipeline, how you can do the blue green and stuff like that. Is there also a way that in the build pipeline you can sort of at a stage. So to say at stage 1, it's only available on my private VCP, but when somebody clicks the OK button, then it goes to the public or something like that. So like different phases.
I see. Not in the auto-generated pipeline. What I showed you was fully auto-generated, but you can definitely configure that your own. So
Right.
with the CI/CD, depends on what you want to use, right? You can use GitHub Actions if you want to, but here we have Cloud Build, and in Cloud Build, you can also have different phases. You can have different steps. However, it's not a state machine as what you're looking for. So for example, what you can do is to say, upon deployment, right, deploy into internal VPC only. But you have to trigger it another way to trigger the next step, which is to ramp up the traffic or to enable public access and stuff like that. Yeah.
Right.
Yeah. So it's really just a linear sequence of steps, but not really a state machine in that sense.
Mm-hmm. Okay.
Yeah. Yep.
So, Ray, one quick thing, which I'm not very familiar with the overall capabilities, but I believe if we are trying, if we can hook up the serverless triggers or events with some API gateway endpoint.
Yep.
So, are there limitations in terms of the payload, or like what the some recommended that it can respond with? Because what I understand, to the limited knowledge which I have from the serverless perspective, this is a very good use case in terms of your jobs, which needs to be triggered on event based, on nightly basis. But sometimes I do get challenges in terms of the payload it can transmit, because if there are large files, reportings and audits which need to be performed.
Yeah, gotcha. Yeah, I would say the events should just be a metadata. Like the events mostly should be metadata, not like I remember the days of doing file processing, right? Maybe a 500 megabyte file with thousands of entries. Like I wouldn't send that entire file over. However, what can happen is that potentially you store the file on Google Cloud Storage, right? And then the event is really a pointer in the action that you want to take to that particular file in Google Cloud Storage. And the code itself can read the file and then do a split and gather type of pattern. So it can read the files and then generate more events for each of the line items in the file. That's a more typical use case. And then each of these entries then will be processed by some functions behind the scenes, which is pretty automatic, right? And you don't have to worry about scaling.
Okay.
Yeah. So definitely do not send a large chunk of something. Always whenever possible, sending the metadata. For example, I used to have a backend that process. It makes a 3D video. So like I had 18 different Android phones. I'm going to stop presenting right now. So I used to have a process that can link up 18 different Android phones so that it can take a 180 degree photo of me jumping in the midair. And then each phone will have its own photo, right, or video, and then we need to do some video processing behind the scenes. Now, rather than sending the entire video as an event, we store that video into Google Cloud Storage, and then we send in a trigger to process that video, right? And then the function gets triggered, and then the function processes that particular video. So it downloads the video from Google Cloud Storage, do the processing, and then upload the binary data back to Google Cloud Storage in that case. Yep.
Okay.
Cool.
Any other questions?
Hey, Ray. Mm-hmm. Yeah, hey, Ray. It's Danny here. Spring questions. Maybe you have answered that, but I'm not so savvy, I guess, with Spring. Is that if I have an existing on-prem Spring application with most of the feature that in your table that you have shown,
yep.
How are we going to undertake the exercise of porting it to use SpringCloud GCP?
Right.
Let's say.
Yep. Yeah. So I'm going to show the table again. Yeah. So depends on actually. Is there a specific thing on here that you may want to learn about, or can I use any examples? or I'll use two examples.
Sleuth, for example, trace.
Sleuth, yeah. Oh, that's a good one. I love that one. That's by far the easiest one. Absolutely. So you're on-prem, you may have Sleuth, and you may have configured it to use Zipkin, right? So you're running Zipkin behind the scenes. And if you take a look at the pom.xml, assuming you're using Maven, I think everyone here is using Maven, then what you're going to see is you're going to see...
Are you sharing your screen?
Oh, yeah, sorry. Good call. Entire screen. There we go. Yeah, so do I have Sleuth? No. So typically in your pom.xml, you will see dependencies for Sleuth and potentially Zipkin as well, but usually just Sleuth. So you can literally just take that out and then add this back in, and that's it. That's all it would take to start sending your traces to SpringCloud, to our Cloud Trace, rather than to Zipkin.
So this is good. So you're showing how to do hybrid really setup where on-premise app can benefit from this GCP and cloud infrastructure.
Exactly.
That ties into Arash's question, and there was another question similar.
Exactly.
So it means they can use ML API services that you mentioned, or tokenization from on-premise, or anything.
Yes, because all of these services are services. So you can code these services from on-prem. We have customers who do that too. You know, think about centralized logging. Maybe you don't want to keep centralized logging on-prem. You can actually, use the log back here. You can send your on-prem logs directly to Stackdriver if you want to. We also have agents that can do that for you too, like FluentD agents. Or maybe you want to get rid of, some on-prem systems. Maybe, I like Zipkin. I like Zipkin a lot. But in case you don't want to maintain your own Zipkin, then you can, take that application, remove Sleuth because it comes with Zipkin, and then remove some of the properties that you configure specifically for Zipkin, and then just drop in this dependency instead. And what this will do, this actually brings back Zipkin. This actually brings back sleuthing. So everything that you see here is Sleuth, except for the actual sync is being auto-configured to go to CloudTrace. Right. So for example, all the annotation in Sleuth still works. So something like new span, like you can do that. You can say span tag. Right, all of these things work out of the box because it is Sleuth. The only thing different is that we auto-configure the endpoint not to go to Zipkin, but go to CloudTrace. Same thing with logging as well. So hopefully that's really useful. One last note is that I have done some production work for our some of our Alphabet companies. And some of them actually may need to adapt to different environments, maybe not just Google Cloud, right? And one thing that when we evaluate the framework and how to actually adapt the same application to different providers, this type of abstraction was absolutely critical, right? The same question about the config server, right? In one cloud they have a config environment, config service, and on Google Cloud where we can use Secret Manager. Same thing with the database, same thing with Trace, and same thing with everything else. This really makes the application slightly more portable. I'm not gonna say you don't have to rewrite, right, or change your code, right? But at the minimum, you need to change out the dependencies here, right? And maybe some API may have changed, so you have to adapt to it, but it will make that whole process a lot easier.
Very nice. Arash, you want to go back to your question? Because I don't want to cut you off, in the middle of...
Well, thanks, Daniel. Well, I got a couple of answers during the other folks' questions, so I do not have, but I'm going to generalize it just because I'm looking at, finding the solution for my own needs. Let's make it very general, Ray. I've seen this quite often happen basically in financials, that mostly they're following the local essentially, or a private, I would say, Claude is that they just want to use a Claude for deployment. Is that doable? Or no, we have to really do all those code change. Not code change is not a lot from me as a developer point of, let's say as a developer, this is not much to do. It's not right?
Exactly.
So let's say, I mean, merging like 3 layers in one, it doesn't take much time, right? But from the business point of view, this is huge, right? So now my question is that though, can we just take advantage of the Google Cloud? Because I'm doing like a little bit of comparison between Google and Amazon. So I see that this is like very straight to the point, very simple, easy going. You know what I'm saying? Very user friendly, but user friendly for a brand new project from scratch, right? Not
Sure.
for something that we have handy, and often they are even brand new, well maintained. They are the latest, let's say JDK 11 or Spring Boot 2.9 or whatever. But hey, they just want to have, like, for deployment. I mean, Daniel knows, he was in RBC. Exactly what they do, it was just a deployment, nothing else. There was microservices, there was all those nodes, config servers, this, that, but literally there was no dependency between the cloud framework and, I mean, the cloud infrastructure and the framework that they actually code. So
Yeah,
here was
I
my
understand.
question. Can we do that or not? Is it really service as needed or deployment as needed kind of thing, or no? Thank you very much.
It's absolutely as needed, right? Because here I'm trying to develop a new Java application and deploy into one of the serverless environment. But you can deploy any Java application into the serverless environment. It doesn't have to be this one, right? So they're fully decoupled. It's just so that in this presentation we show both in the same sequence of storyline, right? But there are two very different things that are fully decoupled from each other. So if you have an existing Java application you want to deploy, you absolutely can. If it's a Spring Boot application that needs to talk to some on-premise database, you absolutely can deploy it. That's perfectly fine. If you want to deploy into AppEngine, deploy the jar. If you want to deploy into CloudRun, deploy the container image. It doesn't matter what's inside. Yeah.
Just
Yeah.
one question, and that was my one.
What's that?
Abhinish wants to ask something.
Yeah, I just wanted to add one point to Arash question, because I think I'm on the same boat where he might be, because my first stint with the cloud was somewhere around 2009, 2010-ish time, and then there was a long gap, and I'm now coming back to it. So when I initially had my stint, that's when I said that, oh, what the hell is this? I mean, I've been using VMware since past 4 or 5 years. I've been using virtual instances, so why should I go cloud when it's just giving me a machine to deploy my code? But when I see it now, when I'm coming back to it, the paradigm has changed completely. I mean, now it's not about the infrastructure; it's about thinking how to design applications utilizing the power cloud is giving to you. So you're right. If I think a legacy application, it may sound like just a redeployment on a platform, but I think it's basically like it's not lift and shift now. It's no more lift and shift. Minimum, you have to lift, transform, and shift at a minimum.
Transfer. I think there is like yes, in terms of the theory, like I said, I mean, let's say if I'm like, intermediate level or somebody a few years experience, when I'm looking at this and I'm comparing with 10 years ago with the same skill set, this is like really unbelievable in terms of simplicity, in terms of, however, when it comes to reality, we have a reality, what's going on out there and what's on the advertise. You know what I'm saying? So,
so really,
let's say you go to the big bank. Now, the place that I'm working is not actually a bank, but pretty much the same. They have over 1,200 microservices, right?
Yeah.
If the company got a lottery every day, you cannot force that manager, hey, you know what, this is cloud. Not because that cloud is not good. We say how we can transform everything from scratch to the new platform when they are still making money, you know?
But I think I don't think I personally don't advocate for that, because that will never happen. No one can have a big band that just migrate. I mean, we went through this 3 times already. I've been through the whole digital transformation phase, right? I mean, digital transformation is not new. The modernization has been, there for, as far as I started working, every 5 years there's a digital transformation and modernization. And
Yeah, no,
and how much legacy do we have? What I'm trying to say is that
when the size is big, they are not stop working. They are always continuously working, but little by little, right? So
absolutely.
anyhow, it's not really doable to just say, stop, we're gonna do this transformation. However, the advantage is a lot that you cannot close your eyes and ignore. So you have to find the balance in between that at some point they push it. That's what all those maybe silly question came from this point that, okay, can I just deploy? So when you deploy, something is running, and then it's much easier to push. Hey, now they have this, they have that, we can do this, or we can do that, right? But if you cannot do that, and then they cannot see, they say, hey, I'm a manager, I'm making the money is coming, everything is fine. What is the, what I'm saying? The point.
Yeah, absolutely. And I don't think there's any conflict in here, right? I mean, we can deploy, and you can also leverage the services if you want to. And how do you leverage some of these services really depends on the timeline of the business. Not every application can leverage it.
Yeah. One more question, technical. I just want to make it quick because time is almost over. You mentioned about those basically multiple data sources without having XA. So in case of the error, those 2 data sources is going to basically fail and transaction is going to be failed, right? Or no, one is going to go through, the other one is going to be passed. Because
so it depends on the use case, right? Like I said, without XA, you can have a pseudo XA, which means that if you have 2 other resources, if all the other resources are XA, you can have at least one resource that's not XA, right? So the XA manager will be able to manage that for you. If you have 2 non-XA resources, that is okay too, because one of the resources is not XA. But if you have 3 non-XA resources, then that's not a non-starter, in which case you have to coordinate the transaction yourself using like stack patterns or something else. Right?
Because by default, let's say we have one transaction that is added by default or ejected in this Spring Boot, is going to get that, okay, that is failed, is part of transaction. The second one and the third one, I can still add it, but if something goes wrong and I call it, only one of them that was originally set it as a default of a data source is the one that is part of the transaction. The second one is not. So depending on circumstances, that will be failed or not, you know what I'm saying? So it's not reliable unless you go.
Exactly. Yes, exactly. Yeah. I mean, all the semantics are the same, regardless of whether you're using cloud resource or not. It's just whether it's an XA resource or it's not XA resource.
Okay.
Yeah, it's the same thing. Yeah.
Guys, any other questions before we wrap up? Thank you for staying over, Ray.
Yeah, no problem. Yeah.
Any other questions? So did you do the survey, guys? Like there is a form. I think I pasted the link in the chat. Do the survey, and then we're going to do a raffle of 2 items. And I also realized when I was doing intro, I did not share my slides. So you did not see what I was talking about. But the moment I get a slide, I merge them together and upload to SlideShare, so you'll be able to catch up. YouTube recording is going to take a little bit longer to go through. This was a vast topic, Ray. Like we did not go through everything, but you gave the sense to people how simple it can be. And I think it's important even for people, executives watching this as a recording or being here, to see how they can improve business agility. Just because it's hard doesn't mean to stop innovation, because over the time you're going to become too expensive. Somebody else is going to rewrite that, not your company, and you're going to lose your job. So I don't know, Ray, do you want to add anything that's from technology? I think it's not black and white, no big bang. It's sliced. It's like you pick low-hanging fruits and benefit from the cloud and innovate.
Yeah, I think being through several projects already, one thing is that sometimes I've seen teams that chases after the newest and the buzz, right? I remember a project where people are saying, "Oh, we gotta use Kafka, we gotta use Kubernetes, we gotta use this, we gotta use that." Being an engineering team, however, we also have to go back to the business value and the business need, right? So, what business problem do we solve by implementing certain technology? It has to be carefully examined, and that's one thing that I have started to really see and start doing too, which is that during those projects with the Google engineering teams, there are so many choices in technology, and every time there's a choice, we write them down. I don't think I've ever done that in my past enterprise lives, which is kind of like, well, just this and that, right? But we actually wrote them down. We have a pros and cons comparison. We talk about the actual, cost and benefit, and the amount of maintenance troubles we may have. Like, are we actually using all the features? Do we actually need it for our business right now, or can we protect ourselves and hedge against changes? So we start with something easier, and then we grow afterwards. Right. What I'm trying to say is that technology choices really depends on your situation at the time, and it's not static. It changes over time, and you have to be ready for that. And I think that's the biggest takeaway I had. So maybe you're using Kubernetes today, maybe you're not, but it will change over time. Who knows what the service platform is in 10 years, right? Everyone is out, 5 years ago is this one thing, but it just changed within another 2 years, right? Who knows what's going to happen in 10? So be ready for those changes and design properly. That's really what I have learned so far. Yeah.
But Spring Framework has also proved it's resilient to the time changes. I keep abandoning it, coming back years later, always. Like, it's so adaptable to the times. It's so well thought of. So.
Yeah, definitely. I definitely see that, because every application needs a framework. So you either start your own, or you use something that somebody else really written. And the vast ecosystem that's there right now really, really helps with the agility and the speed of development.
And you spliced it up with Kotlin. That's amazing. So that's another. For those of us who get tired of Java, like, this is going to be another.
Too bad I didn't get to ML.
No, that's all good. So it's going to be in the slides. So you have your contact info, and then you were sending the link to your work. Before the meetup, you wanted me to share the link to your work. Is it in the slide deck, or you want to share it here for the crowd? You have, like, everything, like your brain down, which is a huge amount of resources.
I'll put in the slide deck instead.
So that's going to be the gift for everybody. And then you had a survey for the people in companies. Do you want to share that survey here, or put in slide me to share the rest?
The survey is only for it's only for people who are actually using SpringCloud GCP. So if people here come back and start using it, please let me know, because I'd love to get your feedback on all of these things as well.
Okay, I will send that information about that to email to everybody. So now let's just do the raffle draw. So I apologize for not sharing the screen with my intro. There was not much there, but I have to give kudos to the sponsors. So this was what you missed. So Mining Publishing. So when you do the raffle, you're going to be able to draw one of the titles, anything they have. And then another sponsor we have is the C2C Global, Google community for, like, companies, but architects one to another, and you can meet your peers working the cloud here. So there are two draws, and then this is the rest of the slides that I'm going to be sharing. That this was the motivation for the talk. I think we accomplished everything here. You proved that enterprises can achieve agility by going directly to the cloud and using the standard SpringCloud frameworks. Then you also showed a bunch of architectural patterns that architects can do. And then it was jaw-dropping demo for developers. They had fun as well. So I think I'm speaking for everybody here when I say that. So let's go to the raffle, guys. Do you have your names here? Where's the survey? I'm
sorry. I thought
Alexa,
I heard my name.
Okay, so we have 12 people. Anybody else? Can you hear me? Am I on mute, or can you hear me, guys?
No, you're good.
We can hear.
Okay.
Yeah.
Anyway,
Names here. Let's see who was shy. Okay, I recognize a familiar face is Rodrigo. Rodrigo is still with us. Why didn't you put your name? Ah, you put your name. He just used nickname. And then Arash, are you here? Arash, you ask questions you really deserve. And then Ray. Anybody else? John? I don't see your name. You wanna try? Anybody?
So what is the question? I missed the question.
So there was a survey. Any name missing? Are you here and you not see your name?
Oh, okay. I can see my name, yeah.
Okay, so let's do the spin for the first one. So we have two prizes here. The problem with the second prize is going to be hoodie, and it's hard to ship internationally. So if you happen to not be from North America, I would urge you to opt for the digital product that it's easier to deliver. So the first person will have a right to choose. Rodrigo, do you prefer Manning product or C2C jacket? Rodrigo, are you with us, or you just? I guess Rodrigo has left us. So let's see. So I'll give the privilege to the second winner. I happen to know Rodrigo. I worked with him, so I'll keep the prize for him. Normally, if you're not here, I cannot chase you. There is no contact info. You would not be eligible for the prize. So remove Rodrigo. Let's see what the second winner will want, and you will have right to choose. Arash. Oh my God. Arash, what do you want? A hoodie or digital product? Hello?
or he's on mute.
So, could you see my screen? Was I sharing the screen or not? I am.
Yeah.
Arash,
Okay.
you want product or one hoodie? Sorry?
Whatever work best for you, hoodie or whatever the.
Yeah, so you're both from Toronto, so it's easy for C2C to ship it. They had a problem shipping the hoodies outside of North America.
Okay.
So
what is
do you prefer? So this is a hoodie. Like I don't know how much hoodies are worth. This is a Google community, but you're not Google developer, so I don't know. Like, are you? So, and then versus any Manning book. I guess Manning, because
Yeah.
Rodrigo is in GCP. How about that? I do the cut.
Yeah, that's better.
Okay. So cool. So I will stop sharing the screen. Thank you, everybody. Ray, I'm really glad I met you in person. Thank you for coming here, and I look forward to learning more from you. And guys, anything else you want to say?
Just thank you very much for your time. It was great.
Excellent. Thanks.
Yeah, thanks everyone for attending. Really appreciate having me here.
Thank you.
Stay safe.
Have a good night.
Yeah, thank you so much. So I'll share the slides as soon as I get them from Ray.
Okay. Take care, guys.
All right.
Take care.
Yeah, thanks, everyone.
Stay safe. Ciao.